Khalid. So we'll be pleased to present to you and have as interactive a workshop as we can over the next hour and 20 minutes on making evidence alive with the Fast Evidence Interoperability Resources, or FEvIR platform. Joanne and Khalid will be available throughout the session, monitor the chat and the Q&A. And in the last several sessions, there were requests for email addresses. So I added my email address to the opening slide here. And I also added support@computablepublishing.com. If you are using the FEvIR platform during the presentation, and I encourage you to do that once we show that to you, and you have any questions, you can ask in the chat or email us, and one of us can help you during this session. So some disclosures: we all work for Computable Publishing LLC, which is a company set up to help make science computable. And we are also all board members of an international charity called Scientific Knowledge Accelerator Foundation, with many of the same efforts. We produce the FEvIR platform, but we do allow use of the FEvIR platform for free. So we experience living data in action in many other areas of our lives. Imagine when you're navigating from one location to another. We no longer rely on printed maps. We have moved to the digital era and have gone beyond just getting PDFs of maps, but we can interact with it with GPS detector devices and interfaces, and it is fully computable now to be exchanged through many different systems. And we do not even think about what software do we need, which system do we use. It just works for us to help us with navigation. So living data in the modern era can be very powerful and make much of what we do very efficient. But what happens in our healthcare knowledge ecosystem today? We'd like to see the data quickly get into the evidence, but it's hard to process. And we want to understand that evidence to inform the guidance, and we want that guidance to inform action. But these pieces do not fit well together, and trying to work on it is like spinning our wheels. What we really would like is for all of this to be interdigitated and smoothly help move it along throughout the ecosystem. So what is the problem? Well, we are not using the widely available health data and research results either efficiently or effectively to support our decision-making. Why not? We do not share the health data and the research results in a reusable form that computers can process efficiently and effectively. Why not? We do not have a globally agreed, machine interpretable, reusable form for sharing this living evidence. So what if we had it for the living health record? That is made possible today with a standard for electronic data exchange. We can share health data in small units of data, information about the patient identification, the medication, the observation, the specific condition. We can do this with common computable formats like XML or JSON, and there's a global agreement for how to use a living health record in this way. And this whole system is responsive to the needs of the community using it. This is provided through a standard. HL7, or Health Level 7 International, is a standard developing organization, and they have created a standard called FEvIR, Fast Healthcare Interoperability Resources, that have taken us from a time where it was very difficult to work between one medical record system and another, and we're starting to see the concept of interoperability so that we could consider this a living health record. So what if we could take the concepts of a living health record and reach a living evidence record? Now, what does this mean? The last presentation was on the BMJ clinical evidence, and the one before that, we saw the MAGIC app, Magic Authoring and Publishing Platform. And there are many, many systems that could deal with living evidence. Here's an example with 7 different systems. And if each one wanted to convert data about the living evidence to another one, that is 42 different directions of converting data, 42 different transformation tools needed to keep it all straight. And if they're not exactly matching, it can get very confusing by the time the evidence bounces around through so many systems. And there's more than 7 systems out there. If we could take these 7 systems and have a common form for sharing the data, we now only need 14 ways to transfer the data, and we could support greater interoperability no matter which systems you choose to use for your local preferences. So where are we on our path to a living evidence record? In 2015, 14 organizations, all but 2 in Europe, came together to propose a major grant to support interoperability for the evidence ecosystem. It was well received, but not funded. In 2017, at the Guidelines International Network Conference in the Tech Committee, we said, we just need to start doing something. Let's just take one step and start moving towards interoperability. And I was charged with leading the effort to take that first step. I didn't know how we were going to do it yet, but we had to do something. In 2018, I learned about FEvIR, and I learned enough about it to recognize how it provides both a technical solution for interoperability, but also a consensus development solution. How do you get global agreement for such a development? And the problem they were dealing with was on a substantial scale and a related domain to the problem we're dealing with trying to do this for evidence. So in 2018, through 5 or 6 different committees and approvals, got an HL7 approved project to extend FEvIR to evidence-based medicine knowledge assets. EBM on FEvIR became the nickname for the project and describes the effort that continues today. In 2019, we created the evidence resource and the evidence variable resource, which is specific structures, how to make a computable interpretation of evidence and definitions of the evidence variables. In 2020, following COVID, there was a lot of demand for use of these resources for new developments for COVID information, and a lot of opportunity with people saying, let's work together to advance the systems. So we started the COVID Knowledge Accelerator, and that expanded EBM on FEvIR from meeting 1 hour a week to 10 active working groups, now meeting 12 hours a week for different aspects of advancing these concepts. So in 2021, we created more resources in addition to standard structures for defining the evidence, right? The statistics, the variables the statistics are about, the certainty about those findings. We found that the publications, some were in journals in Medline, some were in preprints, which were not in Medline at the time. There were other formats for finding scientific records, and there was no common standard for how to share all the citations. So we created a citation resource for that. And then for all the concepts of risk of bias assessment, certainty of evidence, justification for recommendations, classification systems, information about the information, we created a resource called Artifact Assessment to give standard structures for that. And also in 2021, we created the Fast Evidence Interoperability Resources Platform, replacing the health in FEvIR with evidence and use that to support developing interoperability and the living evidence record. So this is a rapid presentation from a conference on mobilizing computable biomedical knowledge. I'll show you this briefly for some screenshots to introduce the FEvIR platform, but then we will go live to actually see it and give you a chance to go to it and check it out for yourselves. So we started with the foundation of FEvIR and the citation resource, the evidence resource, evidence variable, evidence report. We also cover research study resource to cover the protocols or study records and artifact assessment. And if you want to view resources on FEvIR.net, that's the URL. If you want to go to the website, just put in FEvIR.net. And the actual form for computable exchange is JSON. And this is an example of seeing a piece of data, an intervention definition for not having bariatric surgery in this example, in the JSON form. We also go to a text view, and we could see the same JSON in an outline form to make it a little easier to read. And then for specialized types of information, in this example, we're looking at the evidence variable viewer. In the text view, we've created navigation sections above the metadata to see it in a more human readable, presentable form. You can add resources to FEvIR.net. For that, you need to log in. There's no cost to log in and register. Use your Google account. And it's that simple. And we can add a resource in the JSON form if you know how to write the computable form of the data and submit it. We can click on JSON bulk entry, and without arrangements for scaled use of the system, you can add up to 10 resources at a time if you know how to do this at the computable layer. And we are also developing builder tools to make human-friendly ways to enter and edit any of the data, and it will automatically convert it to the JSON. So this is an example of citation builder, and you could see how you can enter information on different identifiers like the PubMed ID, the digital object identifier, related identifiers like a clinicaltrials.gov record, title, and you could see on the menu many other things you could say about the citation data. We also support converting data from structured forms to FEvIR on the FEvIR platform. We have a Medline to FEvIR converter. You just put in the PubMed ID, and it will create a full citation record with all of the data available in the PubMed record. Clinicaltrials.gov to FEvIR converter, put in the NCT number. It will create many resources, the research study resource and the evidence variable eligibility criteria resource for that. If there are study results posted, you'll get a set of evidence resources to have all of the living evidence from that clinicaltrials.gov report. And an RIS to FEvIR converter, you can add a set of citation data in RIS form, and it will convert it to citation records in FEvIR form. You can collaborate with the FEvIR platform. There's multiple examples here. One, the scientific evidence code system. As if we have time for this at the end of this session, we will actually show you how we are creating standard vocabularies for scientific evidence, study design terms like you see here with the study goals, risk of bias terms, and statistics terms. And as we support developing the standard vocabulary, we also provide tools on the platform for the people developing it. And this My Ballot is, these were the terms open for vote at the time of the development. And I can choose to say, yes, I agree, or no, and give a comment, and we continue working on adapting the terms. We have an early demo here of an approach to sharing recommendations from multiple sources for a similar topic. So you see 3 different populations, different severities of COVID. recommendations about anticoagulation from 4 different organizations. And if we click on one of these, we can then see more specific details about that recommendation. We have a project for the COVID Knowledge Accelerator Initiative here, and you are welcome to join this. It's an open virtual effort meeting weekly, and you can see a weekly meeting schedule here. I'll show you that at the end, and you can find this at FEvIR.net. Find meeting that is of specific interest to you, and you're welcome to join us. So I'm going to take a moment now and show you a live demonstration. So here we're on the front page of the FEvIR platform. We put some of our most active projects here. You can go directly to them if you're working with the COVID Knowledge Accelerator Initiative or eligibility criteria matching efforts or scientific evidence code system development, for example. Some of our builders of specific types of knowledge you see up here, you can create a project and make your own page to manage things on the FEvIR platform. The 3 converters I showed are here, and recently added is the Magic to FEvIR converter. And this is just demo files right now, but the Magic app, Magic Evidence Ecosystem folks gave us a couple of demo files, and we will automatically convert them to FEvIR resources. So we'll go to the Magic to FEvIR converter, and I'm going to put in the name for this project, and we'll use the second example here, GLP-1 receptor agonist example, and it converts the data to FEvIR resources to show this. So if we come down to the associated FEvIR resources, there's a justification resource we'll come back to. There's the recommendation in a plan definition form itself, but there are 2 interventions here, the drug and the standard care, the control group, and there are 10 outcomes in this example. And you see 20 evidence resources. 10 are the control group called comparator evidence here from the Magic data, and 10 are the comparative outcomes. So if we look at one, for example, taking a look at this evidence resource, we're looking in the evidence viewer and the summary. There's an assertion, their bottom line statement that they made for that piece of evidence. GLP-1 receptor agonists probably reduce the risk of heart failure compared with standard care. The population is simply described as adults with type 2 diabetes and CVD and CKD. The exposure, we actually created an evidence variable resource for defining it and show the handling for that is a dichotomous variable. Yes or no, you either did or did not get this drug class. And the control exposure here is standard care, also dichotomous. The outcome in this case is heart failure, which is also dichotomous. And there's an evidence variable for the outcome. And then you see the statistics. There's actually 2 statistics for this combination of variables, the risk difference and the odds ratio. They both have the same sample size, and they both have a 95% confidence interval. And certainty has overall certainty, moderate quality due to serious imprecision, and the sub components were not set in the structured data that we received. There's also classifiers, it's systematic review, study design, randomized trials, and the actual data behind this looks more like what you see here in the metadata, with a lot of structured representation of each particular value and concept in the data. So getting this in structured form like this is useful for converting and displaying in any other number of forms. So we can create an evidence report subject. And what we'll do here, we can add a description if we wanted to. It grabs the title from what we had, which is fine. I'm going to describe the population, which will let me put in some text. And then for the intervention, I'm going to reference that variable definition that we have. So the title for that, I can put in the display, and I can actually reference the resource itself. And I have these things already, just another window for time management to copy and paste and fill this in. And for outcome, let's use a coding. Instead of just putting in straight text, we can actually go from a terminology or code system. I'll use this system here. There's a code in that system for clinical outcomes observed, and I can display that as observed outcomes or clinical outcomes. And I'm going to ignore the study design and citation for this example. So we'll go ahead and submit that evidence report subject. And one of the reasons I did that is I'm now going to generate an evidence report. We have all this structured data. Let's convert that into some type of report. So when I generate this evidence report, it has the suggested title here. I could add to the title if I wanted. Let me just throw in the word example, for example. I can pick the subject of the report, or I could, of course, created it here as well. And let's just select the outcome definitions, the comparator evidence, the comparative evidence. That's what we had in the structured data. And I'm going to select the summary of findings constructor for what report to create. We go ahead and submit this, and it does all the calculations and derives the data. The report itself is really in this form. And in the text view, if we go to metadata, you will see there's a section defining what the column headers should say in the report, and then a section for the all-cause mortality coded as a table row entry with a focus, and that is the outcome definition for all-cause mortality. And then every cell has a section with the source of where it is and what the generated result for the table cell was. But we made a very human-friendly table view, and you could see here for each outcome, we have the sample size, the result without treatment. There is no result with treatment observed because there was no data on that evidence in the data set that we added. There is the result with treatment calculated, which is derived from the result without treatment and the effect estimate and putting it together. There's the effect estimate, which is actually absolute differences, but in the report constructor, the header still says relative effect. So that displays in this way. And then the certainty of evidence that came from the structured data is here, and the assertions, what this means for each of the outcomes. This summary of findings not only handles the dichotomous data, but the last two outcomes in this list are continuous data, one without units, one with units, and you see that showing up in the report as well. So we have the evidence report, and I'm going to note this value. I'm going to copy this and put it to the side. I'm going to refer back to that in a moment. But let me go back and look at the project that we created with all of this evidence. I now want to look at the justification for this recommendation. And here we are showing the evidence to decision framework, or the information about the recommendation beyond the evidence. So we have a link to the recommendation itself, a summary of the recommendation. We suggest starting this drug class, and the strength of recommendation is weak. We see the justification has rationale. There's a summary there. Benefits and harms rated as strong with a summary. Preferences rated as weak. Resources and costs were not considered here. And additional information we saw in the Magic app, including advice and remarks that were added to it. And I noticed in the constructor, we have certainty of evidence rating is moderate quality. And the summary says moderate to high certainty evidence for all benefit outcomes, very low certainty for gastrointestinal events, but that's actually a summary of the certainty of evidence, not a summary of the evidence. So I'd like to change that. So I'm going to edit this recommendation justification. And we're still developing the editing tool, but I'll go to the evidence section, and this summary I'm going to put here. But now this comment here, let me change this, and let's add the summary of findings. I'm going to make that what this type of section is about, but I don't need to summarize it and put it here. I'm going to add a related item. And in this related item, maybe this is there's a lot of codes here, but I'm going to use the justification. This is justification for this recommendation. And I'm actually going to say that this is a FEvIR resource that we're going to use as a related item. And we can describe this if we want as the summary of findings. And we can take that URL that I copied for it, and we'll go ahead and put that here. So now if we update this recommendation justification, we'll see the evidence has a summary of findings with the link to it and the certainty of evidence rating. And we're still working on this. We'll enable this to be a link like we did up here. From the editing view, we can actually see that link, and we go to it and we're back at that summary of findings. So this platform is developed to facilitate the interoperable sharing of living evidence in a common standard form, whether we're working with Magic App or clinicaltrials.gov or any other system. Over time, we may develop specific tools, viewers, and builders to use it, but we also encourage all the other systems out there working with digital evidence to interact with the common standard form for improving interoperability globally. So what I'd like to do is take some time now to answer any questions, and you can go to FEvIR.net, FEvIR.net, and try out different things on here if you would prefer to do this in an interactive way. So are there any questions or chat items?
So there's only one question. I already answered it. Reem asked if FEvIR is available, as in it's a free site, and I answered, yeah. Currently, all the tools available on FEvIR are free to use. Yeah.
So FEvIR is very much in a developmental stage. It is not a scaled authoring and publication platform like we've seen with some other systems, but you can actually author things on here. We have some tools like the citation builder that lets you put in all the information to fully author a citation. And we have some tools like the risk of bias assessment tool that will let you fully create a risk of bias assessment without needing to enter it in the JSON form. And there's many more for the developers to be able to develop in the JSON form to encourage how do you get your system to convert to FEvIR. But as we work with many groups and projects, we'll advance any of the features as needed for the groups that we're working with. So
we have another question. Is it a two-way tool? Oh, can you export to Magic or RevMan? To those specifically, not yet. RevMan. I think we might have talked about that a little bit, right? To export RevMan.
Only converter. So if you can get the data in FEvIR, you can get the data in FEvIR from this. Any tool that's going to use it would then have to convert from FEvIR to their systems. The only converter we've created from FEvIR right now is to clinicaltrials.gov. So if we were to, let me just grab a clinicaltrials.gov record to show you the idea. And if we pick one that has results, we'll see more details how the results are handled. And I'm going to go back to the FEvIR platform, clinicaltrials.gov converter, put in that NCT record, and it will convert this to FEvIR resources. And you can see here, we have a research study resource. There's an evidence variable for the drug infliximab, a location, Tufts Medical Center, including longitude and latitude data, so you can see where it is on the map. And a lot of the when was it registered and the results submitted and all this kind of data. We have the title, the official title, technical details. It was transformed from this URL with this tool, citations and a link to the citation there, and the result, and a link to the citation with the result where it was published. Classifiers like the purpose of the study, the phase of the trial, design, masking concepts, descriptions, associated parties, the sponsor, the lead sponsor. The overall study is completed with this timing. The actual number in the study was 17, and we have a link to the eligibility criteria resource in FEvIR here, where we have the structured data. We have there was only one comparison group in this particular study. We have each of the outcomes that were measured, and then there's a lot of outcomes in this study. But then we have the result, and we have another FEvIR resource for the results, and this will go through all the structured information for the results. If we jump to outcome measures module, you'll see time to improvement in oxygenation. That was their first outcome. There's descriptive information about it. And then this is the evidence for that particular outcome. We can go ahead and look at that. And we'll see the structured data here with median 4 days and a range in that particular piece of evidence. If we go back, we can create the clinicaltrials.gov JSON from the FEvIR, and that is our first tool, converting it back to the structured form that is the original structured data form for clinical trials. If there is interest in converters to other systems where there are resources to support development in that direction, we can do that. So what I want to do is I'm going to jump back to that. Let's see, I'm going to close some of these just because the Zoom control is in the way of what I wanted to show you. But let's say we wanted to do a risk of bias assessment of this evidence. We have this tool called ROBAT, Risk of Bias Assessment Tool, create a risk of bias assessment. And this will let us pick a profile. If we do not, there's literally hundreds of terms for the type of bias. If we pick ROB1, there would be 7 terms. ROB2 is 26. ROBIS for systematic reviews has more. And if we do a generic randomized trial or systematic review, there's many more terms. So let's go ahead and pick ROB2. And we'll just go ahead and pretend we're doing a real risk of bias assessment here. We select a type of bias on the left and choose our ratings, and we can click update when we're done to record it all. So let's say we didn't look at the sequence generation, but we looked at allocation concealment, found it lacking. So we could say the inadequate allocation concealment was likely present, and that would likely impact the results, and maybe that would favor experimental, we think, is that gives a moderate risk of bias. And our rationale, we can say allocation concealment not stated. So if they didn't state it, they probably didn't do it, is our assumption that we're making. and maybe there was a confounding difference, going along as well. And the, experimental group had younger age than control group. And that's why we think there might have been a randomization issue. So we can rate all sorts of other components here. We could actually roll up now to the confounding covariate bias. And given these two components were both moderate risk, we could just say that's moderate risk. And we don't have to write the explanation again. It's down in the details below. And let's say we wanted to come all the way up to bias, and we can rate that as well, based, due to baseline differences. Add a note, just a demo. All right, so let's say we've changed all those things. We filled out as much of this as we wanted to. Now we update it and we get our overall risk of bias assessment rating, and we only filled in the first set, but you can see how that displays the assessments we made in reporting this risk of bias assessment. So we have a very active COVID knowledge accelerator community, and develop tools on the platform as activity occurs within that community.
So we got a question by Yasser, who says, can I use the Medline citation converter to generate a citation map by FEvIR if I upload a published article?
I'm not sure I understand the question. If you have the PubMed ID for the published article, you can put that in the Medline converter and you'll get a citation for it. If you have the PubMed ID for each item on the reference list, you can create that as well. If you are wanting to make a citation map and cover many of these things, what you could do is actually, we'll go to the project builder, and I'm just going to make up a project. We'll go demo citation map, if I understand what this is, a demo of adding citations with and without PMID to show how you might create a citation map. And I may not be understanding the question, but we'll go ahead and make this demo citation map. And now we've created the project. And we can go ahead, and if we just update this, we have an empty project that just says the title and that. But now I want to add a citation to this project, and demo citation 1, and we'll put in a PubMed ID 1, 2, 3, 4, 5, 6, 7. No idea what that is, and just a demo, for example. And we'll go ahead and submit this, and it created a citation resource, the effect of castration and peroral estrogen therapy on some psychological functions, published in 1975. But you see the title and where it was published and the PubMed abstract, and you see each of the authors got pulled from Medline, classifiers about it, the mesh headings, including subheadings, whether they're qualifiers, whether they're a major topic or not. And this one is so far back, it doesn't have related articles. Sometimes you see the citations or comments and things like that. That didn't occur with this one. So anyway, we have our demo citation 1. And if we refresh this, we now not only have the citation added as demo citation 1, we have the option if we wanted to add a reference list for our thing. We'll come back to that. So I'm going to add another citation. And here we're going to say demo citation 2, example without PMID. So it can't automatically convert it and get all the data from Medline. If we go ahead and submit that one, we're in the citation builder, but we'd have to build all the pieces ourselves. So if we said maybe this one has a DOI, and we make up some example dot 123, it was the DOI, and maybe this was registered in Prospero, and 456 is a Prospero number, just making things up. Title added here, and we can classify the type of title. It's the primary title. We could even specify the language if we wanted to. We could add abstracts, add detail on the publication form. And this was published in the Journal of Irreproducible Results. That maybe that's a journal, and it was published on the internet in volume 13, issue 3. And we can put in a date in a structured form, 2022. It was just published yesterday. Or we can fill in, sub details on it, or when it was last revised. We can pick languages. We could actually pick multiple languages. Add pages or accession number, things like that. We could add a URL, any number of URL. So if we said http:/example.com, and maybe that's where we find the PDF for the article, or for the, it's a zip file or a file directory or supplement. We can add other types to the things. We could add all the individual authors. We can add a contributorship summary, list of authors, and spell it out. And maybe that's just an author string to go with it. Add classifiers, etc. So we have all this information. We go ahead and update it. And now we actually generated a citation summary. Title added here was the title, the contributors were a list of authors in this journal with the DOI and a link to the URL that we made up. So if we go back, if we refresh this, you'll see now we have 2 demo citations associated. If we generate the reference list, we I'm curious.
I'm curious.
Why maybe that's based on the PubMed ID, and we have to go back and look at why it's not adding demo citation 2 to our reference list.
But
we are developing. Go ahead.
Oh yeah, I was gonna say, but either way, it's like, it's working for one of them. We'll figure out why it's not working for the other.
Well, we're developing this as we go, and our project so far, everything has been in PubMed.
Yeah, so I guess we never tested it.
And try it with a reference list for that, because we are using this effort in a project, Research on FEvIR, and learning about 200 publications of FEvIR-based tools and initiatives to support clinical research. As we work through it, we have made all these links to things we learned about, and then we actually have cataloged 42 citations so far, and then our reference list is like an annotated bibliography.
Right.
But everything has been in PubMed so far, so we haven't run into it. So we'll look at that later.
So in the chat, we have a few things to cover.
Okay.
One thing I would like to do is just real fast, is just go to the FEvIR platform, and we're going to use the PubMed to FEvIR converter, right?
Okay.
Medline citation converter, I should say. And we're going to put in this number just as a start: 277 13072.
Okay.
Okay. So this is Yasser's citation here, and he's asking if he wants to see the map of articles that cited it. Currently, we don't support that, but that'd be very nice to have in our system, possibly. There's other citation managers that handle it, but
it doesn't show from Medline any mapping.
Yeah.
If we don't have anything to automatically detect what cites it, but you can create a project to list your own citations. So what I mean by that, if we go to my FEvIR resources, which mine will show a lot more because of managing the whole system. But if we go under project resources, here is my bibliography. And if we look at that project, here we go. So if we look at that project, this is a list of my citations. So it's, you know, it's things I published as opposed to things that cited my article, but the concept is the same. So I can add my citations and then choose if I want to make an annotated reference list or not, and do that. We also have COVID Knowledge Accelerator mentions in publications. And if we look at that one, there's 10 citations now that have mentioned the COVID Knowledge Accelerator efforts in some other, you know, publication. And then again, we annotated a lot of the particular parts, but we can go direct to the, you know, URL for where it's available, or go to the citation for each of these things.
All right. Yeah, so there's that. There's also another question by Sammy. I used to use Ottawa Newcastle tool for ROB, risk of bias assessment, and SysRev. I wonder if I can use risk of bias assessment tool only in this platform without work on other sessions of the platform. And yeah, I think the answer to that is yes, you can use just that one tool.
To access the risk of bias assessment tool, you need to cite the thing that you're going to make an assessment of. So if we, you know, go back to that demo example, and if I go back to my FEvIR resources and go to projects, I should see one that starts with demo. Obviously, I have demo. There we go, demo citation map. So let's say I wanted to do a risk of bias assessment of this one. I can click on it directly and click ROBAT. I actually, in the project, we've added an enable ROBAT that allows project viewers to use the ROBAT. If you wanted to say other people can do a risk of bias assessment of the things I've listed in my project, we can enable it here. And now we can click rate risk of bias from here as well. But that would get me into the tool. There is no profile here right now for Newcastle. With enough interest in using that, we could make a profile specific to Newcastle. So if we selected ROB1, for example, only 7 types, and you look at the 7 choices, you may recognize that that's a commonly used risk of bias assessment with only 7 choices for randomized trials. If we did this with no profile, there's literally over 200 different terms for risk of bias. And we can shift to how we're developing those terms and how you can be part of defining the risk of bias or study design or statistic terms for helping to define science. Based on the question. Yeah, go ahead.
Before we move on, Gada asked if this produces an ROB table. You show the table that it does produce when we fill in the.
Right. So if we, I mean, this one will be a simple table because there's only so many choices, but I'm just going to randomly click different things in each choice just to show you, you know, some of the concepts not shown with a choice. And I'm just, you know, my choices may not even make sense because I'm just doing a demo, but we click through a number of these things now. And then we can go to bias. We see a summary of 4 of the things that we clicked things on, and then we'll go ahead and summary statement here. Now, if we go ahead and we update this, you know, this is a table for the specific components of the risk of bias. Now, what you might be talking about is a risk of bias assessment table that has the risk of bias rating from each of many studies. This is an individual item. So similar to that summary of findings table, we can build constructors to create different reports based on the structured data that we have. At the moment, the only constructors that we have created, and when I say constructor, that's the rules for generating a table. We only have 2 constructors right now. This one has outcome importance ratings. I can show you the second constructor. But when we generate evidence report, if we have a bunch of these things, we can make a summary of findings table, which I've shown you, and we can make a summary of net effect contributions table. And that one takes the desirability of the outcome, the relative importance of the outcome, the effect estimates, and calculates a, kind of balance the overall net effect, benefits and harms to put together. So over time, as we get specific needs for certain other tables that can be generated from the structured data, we can make another constructor, whether that's a risk of bias table or comparison of recommendations table or whatever that may be. There's a lot of potential developments yet to come. We are primarily solving the problem of interoperability to enable, hundreds or thousands of other systems that can make tables and interfaces and tools and publishing platforms and facilitate data exchange between them. But as we do that and people work with us, we're bound to develop some of these specialized constructors, table producers, data entry forms, as it fits different project needs.
Yeah, so Yasser has another question that was following up on his earlier one. So it's in the chat, but all of these linked articles need to be added / uploaded manually one by one to be able to link to one root article. They cannot be pulled out from PubMed or other databases by FEvIR, right?
Yes and no. When we use the clinicaltrials.gov converter, we generate a lot of citation links from however many is in the data set without having to manually add each one. If we use the magic to FEvIR converter, we again create many. We took a German guideline in structured data, this S3 light linear endometrium carcinoma, and automatically converted that one guideline, and it had 215 recommendations and 204 uniquely identified citations. A citation could have been used in more than one recommendation, and that automatically created 215 recommendation links here and 204 citations. So that was not done, one at a time. But to do things in bulk, you either need to be able to have the data in the right form and enter it here to enter it in bulk, or you need to provide it in some structured form that we're able to convert. So if you have all the citations in RIS form, you can go to RIS to FEvIR converter. And I don't know, Joanne, if you happen to have a data set of citations in RIS handy to throw in the RIS here and show what it looks like, or we can come back to that. But here we can actually add the RIS set, the way it looks as structured data, and it will create the JSON output with all the citations that can be loaded. But we need a way to get a structured set. We do not have a batch medline, list. So I don't think there's an easy way to just put in a series of PMIDs and get the bulk upload. that could be developed as we figure out what project we're working with to support that.
I don't have a collection of RIS ready to go, but maybe somebody in the audience does that would like to share.
Okay. So should we respond to other chat items or move to the scientific evidence code system?
There's besides the RS thing, there isn't anything else on the
Okay.
docket.
All right, so we can
You want, yeah.
circle back to that. So now that we have a standard structure for living evidence, why don't we all just use it and share it easily? What's the problem? Well, we're not speaking the same language when sharing descriptions of the evidence and assessments of validity or certainty of the evidence. Why not? We do not use agreed upon terms with agreed upon definitions for how evidence and evidence certainty is classified. Are we talking about indirectness or external validity problems? Why not? We do not have a globally agreed machine interpretable reusable form for sharing classifications of the living evidence. So we have been developing code systems or structured vocabularies for science, addressing study design concepts, risk of bias concepts, statistic type, and statistic model concepts. And our guiding principles in developing code systems for science are transparency, everything is open and shared, accessibility, consensus, and a universal approach. So we really look for global 100% agreement to say that is the term. We developed a 13-step protocol to systematically do this. We have open calls to many groups, including the International Society of Evidence-Based Healthcare listserv. Anybody can join an expert working group. We identify the existing tools and systems like Ottawa and Newcastle tool for risk of bias use, create non-redundant term lists to meet all the needs across the currently used tools and systems, then and gave some structure categorically to it. We then search for existing glossaries, ontologies, where the definitions may already be done, and mapped all the terms to what definitions are out there. And then looking at all of that, then say, what do we think is the final term for our system? And it then goes through an iterative approach to voting by the expert working group. If there's any disagreement, then we continue to refine until we reach 100% agreement. There is a method to move through with high majority if we do not have universal agreement, but we have not had to use that yet. And then once that's done, then we'll publish this and develop systems for maintenance. Well, we were doing this for a while and then said, why don't we combine the statistic type and statistic model code systems into one statistic code system? And we're actually coordinating with statistics ontology there. And then why don't we combine that with the study design and the risk of bias code systems to what we now call the scientific evidence code system. So we have the same method and same expert working group across the entire set. And we'll go ahead and take a look at the scientific evidence code system that we're using for developing all of these terms. So in the term detail view, we could see in a hierarchical order on the left, how study design contains interventional research, contains randomized assignment, contains the specific types of randomization, the concept of adaptive randomization, for example. You can see that 8 people voted on July 19, 2021 on this version, but 1 said no. July 26, 7 people voted and 1 said no. These are the actual comments with the disagreements that occurred. So we did further refinements. And on August 9, 2021, the third version, we had 9 people vote unanimous approval, and that is now the preferred term in the definition for this. We have comparative study design concepts, study design process concepts, study design feature concepts, and so on. So we get the bias, and there's many different types of bias. And we have an analysis bias. A lot of these are approved terms. You see this one says draft. Inappropriate modeling of censoring is still open for voting as we're getting feedback. And one of the things we did, so you see I have a vote button here for one that's open for voting. We go to reporting bias. We set this up as a term in case we wanted to see what it was like to comment and vote on the term. So we have the definition: a bias due to distortions in the selection of or representation of information in study results or research findings, and a comment for application which shares what the definition of bias is. We have externally mapped definitions. The catalog of bias has this information. The QUIPS tool has this statement. ROB2 has this statement. Robbins I uses the phrase bias in selection of the reported result. And this was open for voting this past Friday. And it has child terms as well. There are 2 votes so far, but we've decided we will not make individual votes open. The comments are open. If you add a comment, you can come to this term and add a comment, and then the comments will make open for everyone to see. The votes I'll keep closed. I can see it as the administrator. But if you make a vote, you can see your own votes. So if I go ahead and I comment on this term, then it can just be just a demonstration of commenting on this term. And I go ahead and submit. Okay, my comment is submitted. Now I can see there's 1 comment on the term, and there it is. If I wanted to vote on the term, it's going to check, am I part of the expert working group? And you can join, if you would like. I can either vote yes, I agree with this term, or I can vote no. If I vote no, I cannot submit. I'm required to make a comment. So in this case, I'm going to vote yes. I could still make a comment. I can still comment when voting yes, just for demo purposes. So I'll go ahead and submit. And now you would see comments and you would see your votes. So I could see my vote on the term. And you'll notice now there's 3 votes on this term. So if anybody in the audience is interested in commenting on the reporting bias term, you could, of course, just comment in the chat to give us feedback on this. But you could also go, and I'll put a direct link to the term in the chat, which will get you right to looking at reporting bias. And if you want to comment, you can click comment, and it'll show publicly, what comment you decided to share. And to add a comment, you would have to log in because it has to give, it has to associate it with you. Someone else cannot edit your comments. Actually, you cannot edit your comment after you submitted it either. Maybe you can. You probably could find your comment and edit it in the JSON if you understood how, but we didn't make an interface to go back and edit comments. Okay. So I want to make sure we share here, if you want to participate in the COVID Knowledge Accelerator Initiative, all the meetings are at the same Microsoft Teams room, and this link will get you there. You know, if you get a copy of the slides, you can get there. You can also go to the COCA initiative page on FEvIR.net. You can email me, thealper@computablepublishing.com, if you want to be added to a daily email list with an update on across the project. I send an update email each day of what happened. And this is the regular weekly meeting schedule. We periodically change it based on the interests of the working group. But we have a group on Monday morning called Research on Fire. I showed you we're working through articles that are published using FEvIR to support clinical research. And it's like a journal club learning about those articles. Later on Monday, we have an eligibility criteria working group. How do you define the inclusion and exclusion criteria for, you know, a set of people in a structured form that might be useful for clinical trial matching services or clinical decision support, matching the patient that fits getting the recommendation that you're making. Common metadata framework is a bit abstract to help facilitate conversion of data from one structured form to another structured form. Research design has been focused on the study design terms, and we have 75 terms now approved, and the group is now focusing on a publication to introduce that to the peer-reviewed literature. Knowledge ecosystem liaison, we often meet with people from other consortial groups to figure out, this is all overwhelming, you know, how do you work with us? Where do you fit in? And figure out how to work between projects. Statistics standard and terminology is mostly working on defining the statistic terms in the scientific evidence code system. The EBM on FEvIR implementation guide is developing the technical instructions to help developers. How do you implement all of these resources for living evidence? And then the computable EBM tools development is working on developing the tools. Some of the things we asked about, do you have a tool for this? Do you have a tool for that? The current tool for priority for development is the recommendation justification builder. And you saw how I was able to edit some parts of the recommendation justification, and that can ultimately help concepts like guideline adaptation to reuse and adapt some of the structured data behind recommendations. And then risk of bias terminology and tooling. You've seen the risk of bias assessment tool and the definitions for risk of bias terms that we showed you. And then communications is pretty self-explanatory, but we focus on, you know, website concepts, presentations, publications. So I welcome you to join any part of this effort that is of interest to you. And happy to answer any other questions or.
And yeah, no one came up with a RIS, you know, a script or whatever we want to call it, but I did find one that we can, you know, show and demonstrate. Oh, didn't paste in here. It's not going to let me paste.
It's too big to paste in there.
Yeah, so if you have Teams open, I'll send it to you through Teams then.
Okay, I do.
I did actually email you a couple as well,
Okay.
Brian.
Okay, great. So I'll go to RIS to FEvIR converter.
Maybe Joanne's would be better because I just literally picked a random PMID.
Oh, you did a single one.
Oh yeah, do Joanne's then, yeah.
Okay, well, we can start with a single, then we can come back. So anyway, this is one record, you know, single example. And this is what RIS looks for this journal. There's the title, there's authors, the abstract, and a bunch of keywords in this case. So first we're going to map this RIS, and we can see that we're going to map TY to type of reference, title to title, abstract to abstract, PY to the year, and sometimes things don't don't follow the standard mapping, and we have a way to suggest changing the mapping for anything. So SP, for example, in this case is the start page and EP is the end page. But we've seen other systems not using the standard mapping. This one looks like it uses the standard mapping. So we'll just go ahead and convert that RIS to FEvIR. And now we have a citation resource in the structured form, that has all of that. And this just shows you how large it is to see all the data. And then we're going to copy that JSON. And with that copy, I'm going to go to add resource JSON, paste it here, and go ahead and submit. Resource type field is missing from the JSON. How?
This is it's a collection. So this has to be the bulk.
Oh, because it's meant for a bulk and this was a single one.
Right.
Actually, what we could do is we
go
can bulk entry, even though it's just one, and then submit. And now all resources were successfully submitted. The difference is we don't see the resource because I didn't associate it with a project ID. So if we did this with the single resource item, then and we submit it, it will submit it and then put us immediately on the record we submitted. And now you see the citation for it. If we, and there was a lot of keywords, right? In this one, there's a lot of keywords with it. So if we are going to submit it in bulk, what we could do is know what project we're going to submit it to. So I'm going to find my way back. This is a project demo citation map. And there's a project number. So I'm going to come back to that with the bulk submit. So now we'll go back to the RIS to FEvIR converter. And in my email, opening a file. And if we copy this file, and we map. Now we got a whole bunch. Do you know if this has, yeah, you see N1 says Ryan inclusion. So this is from a system called Ryan. And the Ryan system has some nuances in it that are different. AV is affiliation information for the book email address as well. It's a combination of information about the author. And SP here, start page, is actually the full range of pages. And the accession number is Ryan's unique number, not the database accession number, where the journal is. So for us to properly handle this in the mapping, we recognize for AN, we're going to make it go to the Ryan accession number instead of the traditional accession number. And if access date, but Ryan uses it for publication month. So we're going to reroute that RIS, and Ryan uses this as a page string, and AV was not mapped. So we're going to use it as the affiliation string. And then Y3 was not mapped, but in Ryan, they use it for publication day. So RIS is not the same RIS across all systems. So now that we modified the mapping to fit the Ryan data RIS, and we convert RIS to FEvIR, we now have, you'll see that there's a lot more because there were multiple items there. We'll copy that to the clipboard. And I'm going to go to add resource JSON. We'll go to the bulk entry. We'll paste that all in here. And now I'm going to grab this project number, because now when we submit, all resources successfully submitted. But now when we look at this project, we can see, 7 unnamed project. I didn't give it a name for the project on the earlier page, but you see RIS to FEvIR converter result 1 of 7 all the way to 7 of 7. And if we click on one of those, then we see that that was converted to the title, the abstract. And although there is a PubMed ID, it did not use the Medline converter, which would have put in PMID and DOI. It just converted the data from RIS, and it just happens to have a PubMed link in there as well. Because the RIS data doesn't isolate the PMID as one of the data points, at least in the data set we just got from RIS, or from Ryan. So
it took 5 minutes.
replied.
Yeah, so one thing you could do is maybe update the reference list just to see if it would work. There's a good chance it won't because it's not a Medline conversion one, but let's see.
So if we let's first refresh, make sure, yep, we have this, and then we update reference list. And
It does
there
work.
they are.
So there's another reason why it didn't work for the other one. Maybe it's even a crash for some sort of data is missing. So we'll look into that.
I may have done such a limited data entry because it was just a demo to show here, you'd
Right,
see
right.
builder, that maybe I didn't fill in something that's pretty
Yeah.
expected.
So what we'll do is on local, we'll see and we'll look for any error messages and see if that's the cause.
Yeah.
Yeah.
Yeah, I don't know what, we can go back and look at it and see, maybe I just didn't put in the right data.
All right. So we have about like 3 or so minutes left. So if anyone has any questions or if they want to see anything else with our platform, we'll be happy to show it. Or if you want to have a discussion or you want to see a feature on our platform, please let us know.
Yasser asked where you find the RIS data of an article, and it used to be that when you went on PubMed, you could download RIS. They're not using that anymore. But if you use Zotero or EndNote or any of those citation managers, they use RIS as the basis of their database. So that's where the RIS structure is mainly used.
Well, hopefully this gives you a glimpse of the future when whatever system you're using to facilitate your creation, use, implementation of living evidence, you see how it will ultimately more smoothly move between systems, and we'll be able to count on it just as easy as we can count on getting directions for navigation as we do today. Thank everyone for your attention, and